السلام عليكم ورحمة الله وبركاته. طلاب الفرقة الثانية شعبة اللغة كلية التجارة جامعة المنوفية. Today, inshallah, we are introducing one lecture in the course Principles of Statistics, Numerical Descriptive Measures. Before we introduced how to describe or how you can organize the data in some tables and graphs. في الكورس بتاع مبادئ الإحصاء احنا وصلنا لغاية Numerical Descriptive Measures mainly in the lectures. طبعا قبل انقطاع الدراسة احنا عملنا covering the Numerical Descriptive Measures، لكن النهارده ان شاء الله هعمل يعني زي ريفيو على البوينت دي وابدا اعمل يعني in somehow explaining the points in details. So in general, in numerical descriptive measures, we have different dimensions to describe the data that you have. You can describe a center, you can describe a variation, or you need to describe a position, or you need to describe the skewness of the shape in the data. So first, before introducing how to calculate each one and how to explain the meaning of the results that you have, I need to give overview why we have different dimensions to describe the data and what is the meaning or the idea of the numerical descriptive measures. So first, let's assuming we have some data in one table, just as a notation, assuming we have that table, and very simply assuming we have that table, okay? That table actually contains data, assuming that whatever the data inside that table, and based on what we had before, what we had in the organizing the data in some tables and graphs, assuming we have a histogram for this data, assuming that we have a histogram or the bar chart, it doesn't matter indeed, no difference, but now I'm assuming we have the histogram to explain the idea for the numerical measures. So assume this data can has one of these three histogram plots. So assuming the first one is symmetric, so that and somehow the symmetric data, or can be skewed to the right, so that the skewed to the right graph, assuming that we covered all this point, that is skewed to the right. No, it's not that. So we can add another one. So that is skewed to the right. We have the tail to the right. And then the last case we have is skewed to the left. Okay, so we have skewed to the left data. So anyway, that roughly introducing the idea for the histograms. We said based on that we have the distribution for the data. For the graphs only, you are visualizing the data and you're getting information about your data. Today, we are not using the graphs. Today, we need to explain how to use some measures, some formula, equations to describe or summarize some characteristics of your data. So we have different characteristics or we have different dimensions to summarize your data. One of these, we need to summarize the first one, we need to summarize the center of the data. Assuming now I need to describe the center in my data. That means I need to find out the typical value in my data. So that then somehow if you are looking the values of the variable that you are describing, assuming that it's from 0 to infinity and somehow, and then based on that, what is the typical value on the graph? On the graph, mostly it will be, this is the typical value, so that indeed describing the center in your data in somehow. I'm saying in somehow, roughly describing that. So on the graph, we can find out, from the graph, we can find out the center for the symmetric, mostly that the center of the data, the typical value. Second, the center of the typical value means the averaging somehow, means you are averaging the values, and that will be the average of the center or in somehow the typical value in your data. Okay. Second, if you have a skewed to the right, mostly, I'm saying mostly it will be the center, it will be that value. From the graph, the center will be that value. If it's skewed to the right, then skewed to the left, mostly that will be the center or the typical value in your data. So now the question, from the graph, yes, we can expect where is the center or the typical value in my data. Now I need to find out, I need to use some measures to calculate that center, or that typical value. We have different measures, okay? We have different measures. So we have the mode, mean, median, and we have other measures indeed, okay? So now assuming these, the first idea. So first, if you have data, you need to describe a center or the typical value, then we have different measures, mean, median, mode, and other measures, okay? Second point, I don't need actually to describe only center. I need to describe the variation around the center. How does the data vary around the center? Okay, the variation around the center. So assuming and somehow that the variation around the center in the case of the symmetric, okay, and assuming that the variation around the center in the case of skewed to the right, and so on, and that the variation around the center. So now if I need to find out the center, the red value, I'm using one of these measures. If I need to describe the value of that variation around the center, I have some measures indeed. We have the variance, standard deviation, coefficient of variation, and we have other measures. Range, sometimes describing variation in general, not the variation around the center. So I have data in one table. I need to describe, or I need to calculate, or I need to find the center or the typical value, just the centralized value in my data. The value that I'm expecting, mostly any value for that variable that I'm actually studying, it will get that value, then you are using a center measures. If you need to describe the variation around that center, the increasing or decreasing around that value, we name it at the spread or the variation measures. We have some measures like a variance, standard deviation, or coefficient of variation. Okay, sometimes we don't need to describe the mean or the center. No, we need to describe the position for a specific value. Assuming we have one value here, assuming that x value, okay, that the x value. And now I need to describe what is the position of this value x among the entire data set that you have. This value in the low level or the high level or in a specific percent of the data. Okay, what is the position or the location of this value? Then we have some position or we have some location measures like the quartiles and the percentiles. And the last point, I don't need to describe the center. I don't need to describe the variation around the center. I don't need to describe the position for a specific value. No, I need to describe the shape or the distribution of the data. I need to say, what about the distribution? It's symmetric or skewed to the right or skewed to the left. What is the meaning of the shape or the skewness of the data? Mainly means where is the position of the center value. So now, return back for the idea for the center. Now, in the first graph, the center mostly in the middle. If you look at the range for the values of x, then it's center, actually, the center of this data at the middle level of the variable values. But that variable has values from 0 to infinity, and the center now mostly in the middle. It's centralized in the middle. Now, what about the skew to the left? Skew to the right, you'll find mostly the center at the low level. It's very close to 0, more than closing to infinity. Okay, so the skew to the right, the position of the center, it will be at the low level for that variable. For the case of the skew to the left, what is the position of the center? At the high level for that variable. So now I have different dimensions to describe my data. So again, if I have data and I need to describe the center, I need to calculate measure to give you the center or the typical value for the data. Then you are using mode or mean or median. No, I need to describe the variation around that center. Then we have the variation measures like variance, standard deviation, coefficient of variation, and sometimes we are using a range, but I need to say the range has actually some disadvantages. Okay. Sometimes after describing a center and the variation, and you have a specific value, and you need to find the position of this value among the entire data set that you have, then you have to use some measures to describe a position for this data, for this value which you have. And then we have some measures like quartiles and percentiles, and you can find out the position of the value that we have. At the top, this value now mostly at the top of the 10%. So now if you look at the value of X, it's at the top mostly, you can say that, assuming that roughly that the 10% of the data, then the value X mostly at the top 10% of the data. So now I need to find measures to telling me that the value of X at the top 10% of the data, or if you have another value Y, we can say value of Y at the actually the smallest 10% of the data. So we need to find some measures to describe a position or the location. We have the quartiles and percentiles. If I need to describe in general the distribution of the data, asymmetric or skewed to the right or skewed to the left, which means you need to find, about describing the skewness, indeed you are describing the position of the center among the entire data or among the levels of that variable which you are studying. So that's the general overview for the numerical measures. Why we have different numerical measures? Because we are describing different characteristics for the data which we are studying. So if you are calculating mean or median or mode, why? To describe the center or the typical value. If you are calculating variance or standard deviation or coefficient of variation, why? To describe the variation around the center. If you are using quartiles or percentiles to find out the position or the location for specific values in your data. If you are calculating the Pearson coefficient, the Pearson skewness coefficient to describe the distribution of the data, and that means you need to find out what is the position of the center on your data at the low level or the medium level or at the high level. So each one of these measures giving you different information or describing different characteristics in your data. So now we can start first in this lecture actually. We had the overview for all the numerical descriptive measures. Indeed, we have other dimensions and we have other characteristics for the data can be described, but indeed in our course only we have these 4 dimensions. Now we can start with how to calculate the central tendency measures and how to calculate the position or the location measures. And the next part of that lecture will be another actually a video describing the variation measures and the skewness coefficient measures. Okay, so now we can indeed start that point. So first, how to calculate the measures that we have. So now just we can clear all that. Okay. So I'm describing now how to the central tendency measures, starting with the mode. So very simply, what is the meaning of the mode? It's very simply the mode, one measure to describe the center and calculated at the value with the highest frequency. يبقى المود هو one of the measures to describe a center. Yes. And we are using the mode to describe a center. Yes. How to calculate a mode? Very simply, the value with the highest frequency. Okay, or most frequently value. So now assuming this data, that very simple example for the annual salary. And now we need to calculate a mode, just to check the values of the salary and select the value with the highest frequency. I think just very quick, you can find out that the value 6,000 has the highest frequency in your data. Then we can say yes, the value 6,000 is the mode. Then we are describing the typical value in my data can be 6,000 in that 60,000 in this case. So the center or the typical value in my data, I'm expecting any annual salary to be around this value, around 60,000. So that very simple measure we are using. Later on we can discuss that. In the mode, sometimes it's not unique. One of the main disadvantages for the mode, it's not unique measure. In some data you have more than mode, and in other data we don't have mode. That's the main disadvantage for the measure to describe a center as the highest frequency value. Okay, the second measure, as we said, mean. Now I have to give general ideas for the mean indeed. المين in general calculated as sum of the values divided by their number. يبقى المين هو one of the measures to describe center. How to calculate sum of the values divided by their number? We are saying sigma x divided by n. Sigma x is sum of the values and a number of the values, and that denotations to explain the idea. But now I need to, in that point, I need to differentiate between the population and the sample mean. So in general, if I'm putting one table, very simply, I'm saying that to explain the differences. So that if you have population data, if you have, I'm using actually that, okay, and you have sample data. So how to calculate mean? يبقى in general mean is sum of the values divided by their number. يبقى mean sum of the values divided by their number. But if you are calculating mean from population data, we are giving a notation as mu. And if you are calculating mean from a sample, we are saying that is x bar. Just to differentiate. But if you are saying mu, that means you are calculating the average or the mean from a population data, and the same formula, sigma x over n, طبعا capital N to say number of points for the population, x bar equals sigma x divided by small n to say that you are calculating the mean from a sample. But anyway, I need to confirm now the same formula we are using to calculate the value of x bar or the calculating mu, but we are saying if you have population data, in notation is mu. If you have sample data, in notation is x bar, and that will be in the second slide. Just very simply, difference between mu and x bar, both they are the mean. One of them calculated from population data, which is mu, and the second one calculated from sample data, which is x bar. So just to be simplified and without any confusion for that point. Okay, so very simple application for the mean, assuming we have the data for the mean and we need to calculate, we have some data. These data from the population, it's given for me now. We have the population data. Yes, it's given clearly that we have the manufacturing company in the United States. This is below the number of, we have a number, and that number it's given as from a population data. If this is information, a sample or population, what is the mean? So indeed, it's population data. Why? Because it's given for all the companies, and we don't have any information saying we have a sample of data. Okay, so it has to be clearly given that it's sample or the population. But in general, I will actually identify or specify that clearly to be population or sample. So now we have mu equal sigma x over n. So just adding the values that we have divided by their number. You have 12 values, then that the sum divided by 12, giving you average equal 195. So that's the way you are calculating mean. There is no actually a challenge point to calculate mean, and we name it as an average from the different courses that we had before. But for the case of the sample, we can have another example to show that it's a sample data. Sample mean x bar, as we said. Okay, now we have another example to say it's sample data. So we have Suncom is studying the number of minutes used monthly. We have a number of minutes used monthly by clients in a particular cell phone rate plan, a random sample. So now it's given directly and clearly in the example that we have a sample data. So in that case, if you are calculating mean, just the same way, adding them divided by their number, the sum divided by the number, but we are saying that is x bar, not mu, just to say we are calculating mean from a sample data, if not from the population. The same formula, just different notations to differentiate. So the value of the mean giving you the typical value of the center. So now, what is the meaning that is typical value of the center? Now look at this data. You'll find the value of the mean mostly in the center or among this data. If you are sorting this data, then you will find the value of the mean in the mostly in the center or in the middle. Then we are saying it's typical value for the data which you have. Now another point, how to calculate the median, the third measure to describe the center. Okay, before that we can give some characteristics for the mean. Yes, we have some characteristics for the mean, and mainly we have two characteristics. The first characteristic for the mean, it's widely used, yes. The first characteristic for the mean that we are using all the data to calculate the mean. For the mode or the median, only we are using one value or two values. One value or more than one value. For the mean, we are using all the values. Why? Because actually you are finding sum of the values. You are finding the sum divided by their number, then we are using all the data. Second, it's unique. Yes, because if you have any data, the sum will be unique, divided by their number will give you unique value. That's one of the main characteristics of the mean. The sum of the deviations from the mean is 0. I need to explain this point indeed. What is the meaning that the sum of the, if you have data, assuming the data is X, and any value in your data, assuming the data, whatever any value of X of this data is X, and now you calculate the mean, mostly the value of the mean is mu. If you have the deviation, the sum of the deviations of the values from their mean, sum of X minus mu, that will be actually equal 0. So that's the meaning that the sum of the deviations from the mean equal 0 or the value 0. So if you have data, assume now, we can give very simple example indeed for that, just to clarify the idea. So assume now we have the values, assume we have only 3 values. We have the value 2, we have the value 3, and we have the value 4. Assuming the 3 values only, and that the values of X. Okay, that the values of X. Now assume it's population, يبقى mu equal sigma X divided by N. So that will be the sum equal 9 divided by a number equal 3. So that equal 3. يبقى the value of mu equal 3. Now I need to find sigma X minus mu, that the sum of that the meaning of the sum of the deviations from the mean. يبقى sigma X minus mu, so that equal each value of X, subtract the value of the mean. يبقى the first value it's 2 minus 3 plus second value 3 minus 3 plus last value 4 minus 3. Okay, 4 minus 3, that negative 1, and that 0, and that positive 1. So that in general equals 0, and that it's general rule actually, the sum of the deviations from the mean for any variable values, it will be equal to 0. And that's one of the main characteristics of the mean. The calculation that you are adding all the values, okay, the same. So that point, return back for the first point that you have all the values are used to calculate the mean, and that the way to calculate the mean. Okay, so now we can move to how to calculate the median. I will calculate the median using simple way, and then we formulate the point. Then we formulate the point that how we can calculate the median in some formal methods. So, the median, the midpoint or the value in the middle. And very simply, the value in the middle, if you are sorting the data and then finding the value in the middle, that will be the median, which is the value that dividing the data into 50% and 50%. And very simply, assuming you have some data, that the data that I have, okay, assuming now we have some data, whatever the data that I have, okay, this is the data. And then this data is sorted. That means that the minimum value and that the maximum value. After sorting the data, the value in the middle, that you have 50% less than, and you have 50% greater than, then this value, actually we name it as the median. But this value now is the median. So from that definition, the median, it's one measure that describing the center. We calculate the median at the value in the middle. After sorting the data, from the definition and from the way that you are calculating, you are saying how to calculate the measure, how to calculate the median to describe a center for any data. You just sort the data and find the value in the middle. If you have odd number of the data, then you have only one value in the middle. It's okay. If you have even number of the values for the data which you have, then you have two values in the middle, and then you can find the average for these two values. I will explain this point. I will explain this point very simply in very simple data, how we calculate the median. Okay, so that example one, we have the age for 5, and then how to calculate the median. Just first we need to sort the data. يبقى arranging the data in a specific order, طبعا ascending. Then we'll find the minimum value 19, second 20, and so on. Now we have 5 values. Then the value in the middle will be third value, 21. Then the median equal 21 for this data. Okay, another application, if you have even number, that you have odd number, it means you can find only one value in the middle, one value in the middle. So now, assuming we have even number, so we have only 4 values. I'm then sorting data. Okay, it's sorted already, 73, 75, and so on. Now find the median, the value in the middle. We don't have, this is even number, we don't have one value in the middle. Actually, we have 2 values, 75 and 76. Then you have to use the average for these values, which will be 75.5, and that will be the value of the median in this data. How to calculate the median? Very simply, for these very simple examples, just sort the data ascendingly and then find the value in the middle. I will give you formal way to find the value in the middle. Just now I'm explaining the idea of the median, but later on in this lecture, I'm discussing in details a formal way to find the value in the middle for any data set and for any size that you have. Okay. Okay, so the median still has some characteristics. It's unique. Why? Because you are finding a value in the middle, then you have only one value in the middle. Approximately, you can approximate that value to be unique. Second, one of the main characteristics that I need to discuss later on, that the value of the median, it's not affected by the extreme or the outlier values. However, you'll find the mean will affect by the outliers. This point I will return back and discuss in details. Actually, this very important characteristic of the median, and that in some applications, why we are using a median and not using a mean. I will return back for this point and discuss what is the main advantage of the median over the mean, that it's not affected, it's robust statistic. That means it's not affected by the extreme values, which is very large or very small, or in statistics we are saying it's outlier data. If outlier values can affect the mean, but actually not affecting the median, and that we can discuss later on. And that very actually important characteristic of the median as one of the measures to describe a center. Okay. Calculated for most of the level of measurements for the ratio, interval, and ordinal data. That one of the main characteristics still, or the advantage for the median. And then we can find that the main characteristic, it's unique, yes, not affected by the outliers, and calculated for different level of measurements for the ordinal, interval, and ratio. Before we start discussing how to calculate the median in the formal way, now I need indeed to give some comparison between the measures. So now what I need to say? I need to say that we had the histogram to describe a distribution. That, as we said before, it's symmetric, and that one is skewed to the right, and that one it's skewed to the left. Now, what is the relation between the skewness of the data and the position of the mean, median, and the mode in the data? We have actually that point. If you have symmetric data, you'll find the value in the middle or the center. Okay, that's the center in the data if it's symmetric. If you are calculating the mean or median or mode, you'll find them, they have the same value, they are equal. The 3 measures, mean, median, mode, they will be equal only if you have symmetric data. otherwise they will be different. Okay, that the relation between the distribution of the data and the position of the numerical measures to describe center and mainly mean and median and mode. So zero skewness, that means you have symmetric data, and in that case we have the values of them, they are equal, mean equal median equal mode. Second point, as we said, if you have a skew to the, get a skew to the right, you have a tail to the right, then you have a skew to the right data. If it's a skew to the right, you'll find the mean, it's very sensitive to the large values. Okay, it's affected by the large values, that the infinity mostly. So now we'll find the value of the mean close to infinity compared to the value of the median. So now this is the meaning that we are saying the median is robust estimator and is not affected by the extreme values or by the outliers. Okay, so now we'll find the mean as a little bit is close to the infinity, or that means it's not exactly in the center of the graph as we have. That mostly we can say that can be the for the data as the center somehow from the graph, roughly approximated from the graph. So we'll find mostly median in the middle, and then we can find the mean, it's a little bit large, okay, in the case of skew to the right, and we'll find the mode, it's less than the median. Why? Because the highest frequency at that point. And how we calculate the mode? We are calculating the mode at the value with the highest frequency, and by logic you'll find the mode, it's very large, it's sorry, and that very logic, by logic, that you'll find the value of the mode, it's in somehow affected by, or we can say it's biased to the highest frequency values. Why? Because you are calculating the mode at the highest frequency value. So now if you have a skew to the right and the highest frequency at the low level, then the value of the mode will be the minimum value to describe a center. Okay, that we have, because we have the highest frequency at the low level, that the definition of the skew to the right data, then you'll find the mode the minimum, then we have a median, and then we have a mean is affected by the extreme or large values, then we'll find a mean the maximum value. In the same way, I need to explain the same idea for the skew to the right, skew to the left, so that the data skew to the left. You'll find that it most of the highest frequency value, so that the value of the mode, and then that we have the small values, very small values, close to negative, assuming close to negative infinity. You'll find the mean is affected by the small values, the very extreme values. Then you'll find that the value of the mean, and then in the middle you'll find a median. But in general, that I need to say, we have relation between the position of the mean, median, mode, or we can say the relation between the values of the mean, median, mode, and the distribution or the skewness of the data that you have. If you have symmetric data, mean equal median equal mode. If you have a skew to the right, the maximum value, it will be a mean, and then a minimum value, it will be a mode, and a median in the middle. All the time you have a median in the middle actually, okay? All the time we have a median in the middle. If you have a skew to the left, a minimum value, how it will be the smaller value, a mean, and the actual largest value, a mode, and we'll find the median in the middle. Okay, so a median value in the middle describing to divide the data in 50% and 50%, and still the value of the median among the mode and the mean, it will be in the middle. That one of the main characteristics and the main advantage for the median, it's not sensitive to the outliers, it's not affected by the extreme small or large values. Okay, now we can return back how we calculate a median in some formal methods. So that will be in our slide. We can discuss that in details, and that indeed it will be the first part of our lecture, how to calculate the center measures. Okay, so I need to describe in this slide how to calculate a median, but in the same time, I will explain how to calculate quartiles and percentiles. There is a relation between the way you are calculating a median and the way that you are calculating quartiles and percentiles. I need this later on. So first, I need to describe the idea for the median, quartiles, and percentiles. Assuming you have this data, that the data sorted, that the minimum value, and that indeed the maximum value, assuming that, okay? So now the value in the middle, that dividing the data into 50% and 50%, we name it as a median. The first 50% still can be divided as 50 and 50. We can say that dividing data in 4 quarters, that is 25%, to explain the idea, that 25%, that is 25%, some of them 50%. And then we have 25%, and then we have the last 25%. In that case, we are dividing data into 4 quarters. So the value that you have 50% less than and 50% greater than, we name it as a median. Okay? In the same time, the same value, we can name it as a second quartile, or a Q2. Why? Because in the same time, this value have 2 quarters less than and 2 quarters greater than. Then in median, the same as the second quartile. If a quartile, you are dividing the data in quarters. If the value that you have 2 quarters less than or 2 quarters greater than, we name it as a second quartile or a Q2. By logic, or in the same way, the value that you have only 1 quarter less than 25%, it will be a Q1. So Q1, the value that you have at 25% less than and 75% greater than. So we name it as a Q1. يبقى median or a Q2, median the same as second quartile, or the same measure indeed, that dividing data into 50%, or 2 quarters less than and 2 quarters greater than. A Q1, the measure that dividing data into 1 quarter less than and 3 quarters less than. In the same way, we can introduce the third quartile. But the third quartile, or a Q3, the value that dividing data to have is 3 quarters less than and 1 quarter greater than. So you have 75%. So now that's 75% less than and 25% greater than. This is the description of the median and the quartiles. For the quartiles, we have a Q1, a Q2, and a Q3. Then we have 3 quartiles, and we have a median, that the second quartile. So we have relation between the median and the position measures, mainly quartiles. Now I need to generalize. I'm not actually only introducing 25% and 50% and the 75%. Assuming I need to find the value that dividing the data into 80% less than and 20% greater than. In that case, you are generalizing from quartiles to be percentiles. The quartiles dividing the data in 4 quarters, 25% each quarter. And the percentiles dividing the data in any percent from 1% to 99%. That means for the percentiles, we have 99 percentile. For the quartiles, we have 3 quartiles. We have 3 quartiles because we are describing the data or dividing data in 4 quarters. And the percentiles, we have 99%, we have 99 percentiles because we are dividing the data in any percent. And somehow I'm saying 99, but we can find any percent indeed can be in decimals. So that not has to be integers. I need to find the value that dividing data into 85%. So indeed, the number of percentiles, we have many percentiles, can be in somehow infinity. Yani, mathematically, we have number of percentiles equal infinity, that mathematically. But I'm saying that in general, assuming if you have integer values for the percentiles, then you have 99, okay? So now I need to explain the idea. The same way which we are finding the median, we can find the quartiles and percentiles. Now I need to do, what I need to now introduce, I need to introduce the way that we can find the median, quartiles, and percentiles in the same way using the same steps, only we are changing the percent that you need to find the value for. So now I need to return back what I need to explain. A Q1, that means we need to find the value that after sorting the data, the value that you have 25% less than. That means for Q1, we can relate that with the Q1 with the value 25%. Okay, that for the Q2, we have 50% less than. For the Q3, we have 75% less than. The percentile, any percent less than, any percent or any P less than. This is now, I'm introducing this formula. I'm introducing this formula to find the position of any percentile, quartile, or the median in the data. Even now I need to introduce the way that we can use P now, means the percent of the data less than the measure which you need to find. Even now I'm introducing one formula to find the position or the location of the median, quartiles, or percentiles in the data. The value first, that formula saying that LP, the location for any percentile, P for percentile, the location for the percentile equal n plus 1 times the P divided by 100. What I need to say, median and quartiles, they are special cases of the percentiles. Even general case, percentiles, quartiles, and median, they are indeed special case. And the median is second quartile. Yani median is special case of the quartiles, the quartiles is special case of the percentiles. So this formula to find the position or the location for any percentile after sorting the data, then we are able to use this formula. Ln, just to explain, Ln, the number of values that you have. Lp, the percent of the data less than the measure which you need to find. That means in LP now, different values. LP can 25%, LP equal 25% if you are finding a Q1. LP now equal 50% if you are finding a Q2. LP equal 75%, sorry, that 2, not a 3. If you are finding Q3, LP now can any percent if you are finding the percentile, if you are finding a percentile. Okay, so that will be generalized, but be careful, a percent that less than, not greater than. So now return back, what is the meaning of less than? Now this percentile, I'm saying 80% less than and 20% greater than. So if I need to find this value, then I have to use LP equal 80, not 20. So now just to confirm, in LP in this formula for the percent of the data less than what we need to find. So now I generalized the idea how to calculate the median or the quartiles, percentiles. So very simply, if I have some data, just we can give data, example for that. If I have this data, assuming we have, first I will explain for only 5 values, assuming we have L value 2, data 3, 1, 2, and then we have 4. We need to find the median for this data using the formal way that I'm explaining. Step 1, just we can put that in 3 steps. Step 1, sort the data. We need to sort data. Okay, I'm using the mouse to write actually. So sorted data, okay, so that's 1, 2, 2 again, and then 3, and then 4. Step 2, find the location or the position using a formula. Even step 2, I'm using a formula. Even LP for the median, I'm now finding a median. Just to know that I'm finding a median or a Q2. LP equal n plus 1 times P. What is the value of n? 4 or 5? It's 5. 5. 5 plus 1, it will be 6. Sorry, we can do that in details. Just okay. So we have number of values 5, n plus 1 times p, LP for the median 50, divided LP for the median or a Q2 50, divided by 100. If you have calculator, they equal 3. What is the meaning of 3? That means the position of the median in this data, the value number 3. Just now count. Just now count. 1, 2, 3. So then the value number 3 equal to, so step 3, find the value, write the value, or find the value. Find the value, just we are saying find the value. Okay, sorry for the error. Return back the example that we said we have a value 3 to sorry. Okay, so again, we said we have only 5 values. We have a value 2, 3, 2, 1, 4. And the question now, we need to find the median. How to find the median? We said we have 3 steps. Step 1, sort the data. Sort the data, first sort data. Then it's 1, 2, 3, 4. Step 2, find the position. As we said, the LP, so that equal n. Now we have n equal 5 plus 1 using the formula, times LP for the median, as we said, it's 50, divided by 100, that using 3. Now, what is the meaning of 3? That means the position of the median in the data, the value number 3. So now just count 1, 2, 3. So now the value of the median equal 3. So just now we can write down that in step 3, the value, step 3, the value of what you need to find the value, then the median in our case equal the value 2, even in this data. So that's using formal method. So very simple, if you have a few data, just you can sort, find the value in the middle. We don't need to use a formula. But now I'm assuming we are using that in general, how we can formulate. So now I find the median or the Q2, the same. Assume now for this data, I need to find a Q1 using the same steps. Okay, I need to change the color now. Now I need to find a Q1. Step 1, the same. Step 2, the same. Just changing from 50 to be 25. For Q1, it's 25. Okay, and then substitute and find the value. Then you'll find actually that mostly it will be 6 divided by 4. Now I need to discuss this point. So we have 6 divided by 4. So 6 divided by 4, that mostly 3 divided by 2 equal 1.5. In the case of the Q1, the position 1.5. The position equal 1.5 for the case of Q1. What is the meaning that the position is value number 1.5? We don't have value number 1.5. We have a value number 1, yes. We have a value number 2, yes. But we don't have a value number 1.5. That means the Q1, the value between the first and the second value. And 1.5 will exactly find the value between 1 and 2, so that it will be average. The value in that case, it will be value number 1 plus the value number 2, then 1 plus 2 divided by 2, so that equal 1.5. Now Q1 indeed equal 1.5. Why? Because you're adding the value number 1 and the value number 2 and finding the average, it's 1.5. In the same way, changing color, I need to find the Q3. how to find the Q3. The Q3, the first step the same, yes. Step 2, substitute, not 50, not 25, it's 75. So now I need to find the value 6 times 3 divided by 4 will give you a position or location for a Q3. So now we have, using a calculator, we can find that out. So we have a value 6 times 3. So that equal 18 divided by 4. So that will give you a value 4.5. So using calculator, the position now equal the value 4.5. So that means the value of the Q3 is value number 4.5. I don't have a value number 4.5. I have a value number 4, yes. And I have a value number 5, yes. Then adding them up and finding the average indeed. 4.5, then find the average for these two values. Then Q3 now equal 3 plus 4 divided by 2. 3 is value number 4. 4 is value number 5. That divided by 2 equal 3.5. So from that very simple example, I explained how to find the median, and we find the value equal 2. How to find the Q1, its value equal 1.5. And for the Q3, its value it will be 3.5. Now, if I need to find any percentile, and that I need to explain this idea indeed now. Now, I need to explain the idea for the percentile. Assuming now for this very simple data, I need to find the value which 80% of the data less than. Okay, which 80% of the data less than. So now I can do that very simply. So now percentile, we can change the color. Okay, just to explain the idea. Now I need to find the percentile, 80%. The percentile for the 80%. Step 1, yes, the same. Step 2, the percentile, that the value, assuming now I need to find the value that I have 80% less than, then we are using a P equal 80. So then we can substitute now with the P equal 80. Okay. Using a calculator now to substitute that to find the value for P equal 80%. What's the value of LP? Assuming now, just we can make it down. Now for this data, I need to substitute now the value of P equal 80, make it down. So not 50, it's 80. Now calculate, I need to find the value. So we have 6 times 8 divided by 10. So anyway, we can find that using using calculator somehow. We can do that very simply. So the general point before that, before calculating the value that we can describe a point, I need indeed to do that. At some point I need to explain, just one second for that. Okay, so I will leave it now. So now I just need to explain this point, and later on I will return back for what I need to say about the position in different cases. So at that point, as we said, we need to calculate it indeed. We said we have the value. So I need to calculate. I'm using now a calculator to have the value. I need it not approximated. I need the accurate value for this case. So we said the value will be 6 times 80. 6 times 80 divided by 100. So that equals 4.8. Okay. So that equals exactly 4.8. 4.8. Okay. So now I need to find the value that 80% of this data less than before sorting the data. So we have using that, we say we are using P equal 80. First step, sort the data, sorted. Second step, find the position. Yes, now the position for that percentile 4.8. Now the question, just to clean that. Now the question, this is the data after sorting, okay? This is the data after sorting, just to clarify an idea. So now we have 1, 2, 2, 3, 4. This is the data after sorting. So now we need to find the value number 4.8. I don't have a value number 4.8. I have a value number 4. I have a value number 5. So now that percentile, it will be between value 3 and 4, but indeed it will be very close to value 4. Why? Because it's 4.8. Because it's not 4.5. If it's 4.5, then it's in the middle between 3 and 4. But now it's 4.8, so now it's very close to the value 4. Okay? Because 4.8 very close to, that means very close to value number 4. So now I need just to explain this idea. I'm putting that in somehow saying we have a value, we have LP equal 4.8. Okay, so that means 4.8, that means it's between the value number 4 and between the value number 5, because the 8 is close to the value number 5. The value number 4, from that we have the value number 4, the value number 4 indeed it's equal 3. It's equal 3. With value number 5, it's equal 4 from the data. I'm just using this data. That is value 3, number 4. That is value 4, number 5. And the position 4.8. So now if I need to calculate, very simply, we cannot use the average now. Why? Because 4.8, it's not exactly between 4 and 5, between 3 and 4. And now 4.8, it's not exactly between value 3 and value 4. Indeed, it's very close to the value 4. Okay, almost in that area. So we have two ways. The first way, just very simply, you are saying whatever, regardless of value, I'm using an average 3 plus 4 divided by 2. And some saying that, okay, just find the value as 3 plus 4 divided by 2, assuming the value in the middle, and that equals 3.5, and that's it. And some way to calculate that percentile in this way, yes, and it's acceptable, but it's not accurate. The accurate way, you have to find the value as weighted more to be close to 4. How I can do that? Very simply, I'm saying that 4.8, it's between the value number 4 and value number 5. Then the value in that case, the value of that percentile equal, first, the value number 4, it's a 3. By using the value number 4, which is 3 indeed, by writing that as a 3, plus the remaining of the order, that is value number 4, the remaining is 0.8, plus 0.8 times the difference between these two values. Difference between value number 5 and value number 4. The value number 5 is 4, the value number 4 is 3. Different times the difference between 4 minus 3. What we are doing now? Now we are actually in somehow calculating weighted average for these two values. I'm not giving the two values the same weight. If you are saying 3 plus 4 over 2, you are assuming the value 3 has the same weight as the value 4, and then each one of them has a weight is half. That's the meaning of a 3 plus 4 over 2, which means half times the value 3 plus half times the value number 4, which means you are giving the two values the same weight, assuming a value in the middle. But now using a difference method, we are giving the weights for the values according to the difference, according to the location position or the position for that value. If you have the location or the position in step 2 is not integer and it's not exactly half, then using this way we name it as a difference method. Difference method, first use it integer value, it's 4, then the value number 4 is 3 plus remaining is 0.8, then times the difference between the two values that you have in position between them. The value number 4 5, difference between them 4 minus 3, value number 5 is 4, the value number 4 is 3, but 4 minus 3, that the difference between the two values that you have in percentile between times the weight according to a remaining of the integer value. Just in summary now, to summarize the point, how to find the quartile, percentile, median. If you have a position, it's not integer value, and the decimal, it's not half. Okay, very simply, 4.8, that for example, you have an integer value, find the value plus a remaining of that location, and that percent or that ratio, that as a weight, plus that weight times difference between the value number 4 and 5, the difference between the value number 5 and value number 4, and that we name it as a difference value. That it's very accurate. Now it's giving you that that percentile equal 3.8. That actually it's more accurate. 3.5 using just the average, it's acceptable, but it's not accurate. But using the difference method, it's more accurate in that way. So any data, we can calculate the median, quartiles, or any percentiles in the same way. First, sorted data. Second, find the position, and be careful if it's not integer value. Third, find the value directly from the data. Indeed, I will explain in somehow for different cases we can use it. But for today, it's enough that we are explaining today how to calculate the we explained in general the overview for all the numerical descriptive measures to describe a center, describe a variation, describe a position, describe distribution or the skewness in the data. Then we discussed in details the central tendency measures, mean, median, mode, and then we described how to calculate the median, along with explaining how to calculate the quartiles and the percentiles. Still, inshallah, next lecture we can continue how to calculate the variation measures with skewness, and we'll return back for the central tendency measures. I will return back for the central tendency measures to focus for some characteristics and some points for these measures. Thank you very much, and I hope that it's clear for you how we can calculate all these measures. Assalamu alaikum wa rahmatullahi wa barakatuh.